Yes.
Okay, so the work I'm going to present, promoting cardiovascular health using a recommendation system, was developed by me and Eduard and Professor Orlando Belo. We are from the University of Minho in Portugal. In a brief way, the work we developed is about a construction of a recommendation system capable of suggesting a 30-day plan for food and exercise that aims to improve cardiovascular health. Uh, in this presentation, I'm going to start to make a brief introduction. Then I will summarize the main motivations and the objectives of our work. And after that, I will talk about cardiac well-being indexes. I will show how the cases were represented and describe the main steps of our work. In this phase, I will describe each of the stages of the CBR cycle that we followed. And at the end, I will talk a little about the program that we created. And then I will present the main conclusions and some possible future work. So, in our daily routine, we are constantly testing our decision-making ability and making choices. And these choices tend to be repeated every day and define our lifestyle, which is directly linked with our well-being and our health, particularly cardiovascular health. Although most people are already aware of the importance of healthy lifestyle habits, only a few are able to incorporate habits into their daily routines. Due to the lack of time and motivation, many of the choices that we make are not the result of thoughtful decisions, and consequently, they are not healthy, especially those related to diet and to physical activity. Planning every day what to eat and what physical exercises to do requires a lot of effort. When it comes to food, for example, it is not always easy to think of new recipes that are healthy and tasty at the same time. To make the best decisions, it is necessary to have the ability to conciliate the personal tastes of each one with the best options for cardiovascular health. This planning is not a simple task and requires four fundamental aspects: time to exercise and eventually cook healthy meals, knowledge to know the healthiest options for each person, creativity to think about new physical activities and recipes, and motivation to stay focused on the main objective of following a healthy lifestyle. One of the ways to simplify this task can be through the creation of a food and physical exercise recommendation system. Knowing which healthiest choices are is not a linear process and depends on multiple variables. Despite being a well-studied area, there are still many uncertainties involved. Therefore, to implement a recommendation system, we have chosen to follow a case-based reasoning approach because it is suitable for solving complex problems and it is very focused on real-world systems. Thus, the aim of our work was to implement a recommendation system based on a CBR approach that guides its users towards a healthier lifestyle. The system was developed based on a diet and exercise recommendation plan to be followed for 30 days. To do this, we use databases to store cases. We built an ontology and defined some SWRL rules to structure the existing knowledge in nutrition and exercise. And we also created, in the end, an application to interact with the users. So before starting the implementation, we thought about a way to evaluate the success of the recommendations. In the literature, we found that most recommendation systems in this area do this type of evaluation by specialists or even by the users themselves. But we decided to create a metric, the cardiac well-being indexes, to avoid external validation of the system. These indexes consider the characteristics of each person and allow to measure in the form of a numerical value the cardiovascular health status of the individuals. Thus, in order to assess the success of the recommendations, we measure the index before and after the fulfillment of each plan. So if the value improves, the recommendation can be considered successful. After defining the evaluation metric, we represented the cases considering 4 different components for each one: a description, a justification, a solution, and the results. And then we store them in a relational database. The first stage of the CBR cycle is retrieve. In this step, we use the k-nearest neighbor algorithm to return the most similar cases, and we here included a threshold that defines a minimum similarity for a case to be returned. After that, we considered 2 possible scenarios: a first scenario in which no cases are returned, and a second scenario in which there are cases returned. For the first situation, we defined cold start rules that must be applied in order to obtain recommendations. And in a second situation, we defined a score function that takes into account the values of similarity, index variation, and degree of success. And the best case corresponds to the case with the highest value, with the highest score. So in the next stage, we adapt the solution using an ontology that we built. In the specific case of dietary recommendations, the first step is to return from the ontologies all the menus that respect the necessary calories for each meal. Then we retrieved the menus that users cannot eat because of their food allergies, intolerances, or diet. For example, a gluten intolerant user cannot consume menus that contain gluten, or a vegetarian cannot consume menus that contain meat. In the next step, we filter the menus that the users can eat. That is the menus from step 1 that are not specified in step 2. If we are in a cold start situation, we need to see which of the menus respect the cold start rules. And if we are in a best case situation, we calculate the nutritional similarity between the best case and the return menus, and we remove the menus that do not have a high similarity. To know which menus should be recommended, we also calculated the similarity between the menus in the previous step and the user's preferences. The 3 menus with the highest value for each meal are recommended, so that the user can choose one of them. The menu chosen by the user corresponds to the system's recommendation. For physical activities, we followed a similar methodology. Although the recommendations are based on successful past cases, there is no guarantee that they will be successful. Thus, after the end of each plan, we need to analyze the success of the recommendation. To do this, we calculate the variation of the cardiovascular well-being index, and if it is positive, we add 1 unit to the number of successful cases, and if it is negative, we add 1 unit to the number of failures. We also need to confirm if the solution of the new case is identical to the solution of the best case. And in this case, we should analyze if the case should be maintained in the case base or not. For this, we calculate the degree of success, and if it reaches a low value, we remove the case from the case base. If the solution is similar and the degree of success is high, the case base values are updated, and if solution is obtained by cold start rules or is significantly different from the solution of the best case, we insert a case as a new case in the case base. Here we have the application we developed using Java FX. As an example, in this slide, we can see 3 options for each meal of the day, and the user must choose one of the options. To conclude, here we have the main conclusions of our work. The system we have built acts as a recommendation system in the area of diet and exercise and follows a CBR approach. The metric for evaluating success is through well-being indexes, and therefore no human intervention is required. Structuring the consolidated knowledge in an ontology allows easy adaptation of the cases, and we created a system capable of simplifying daily decisions and promoting the adoption of healthier habits. As future work, it will be interesting to test the effectiveness of the system using all data, consider remote communication and security issues. For making recommendations about food, it would be interesting to include the quantities of each ingredient in the recommendation and allow different workouts in the same exercise recommendation would be interesting too. So thank you for your attention.
Thank you. Thank you for your presentation. And any questions from the audience? No question. Oh, so I have just a small question. So you use k-means to classify your data. So I mean, what value, what k-value that you choose, because k-value can influence the results. So can you tell us how to choose this?
We only 10 for the k-value because we confess we use k-nearest algorithm, and because it is the more used algorithm in this type of works, and we only choose a k-value of 10 because we already saw that that value would be okay.
Can we choose this value in your software? When you show your software, can we choose this value, or it's fixed?
We use as a basis jCalibri for do that. So we use the k nearest neighbor from jCalibri, and the k value is for default 10. I think so.
Okay, thank you.